it's Don here from the board. Thank you very much for joining me on another video, and in this video we're going to be continuing the series on building our 2x2 PCB following the keyboard PCB guide created by Rui Mao, which can be found on GitHub. So in the previous parts we've run through setting up KiCAD, we've done the schematics, we've done the association to components, and we've also laid out the footprint. And in this video we're going to be concentrating and moving forward on routing. So routing is all about making the actual physical connections of the wiring traces within the PCB so that your components line up and get power and signal both to the USB, to the switches, to all the electronic components, and of course your microprocessor. Now this is probably a stumbling block for me because when I tried it earlier, not on the 2x2 but on a design that I had created myself, probably went in a bit on the deep end because it was quite a large grid. It was a 7x8 grid formation. I think it was probably a bit big for me and I struggled. Hopefully, at least with the 2x2, it's going to be a little bit easier, but you're going to get to see what is involved following what is recommended in the actual guide, as well as it'll give you an idea of where you might go wrong, and therefore you won't make that mistake when it comes to actually doing your own routing and putting traces down. Now this is part 3, but it is actually the 4th video because there is the part 0. So if you are coming in on this series, you can actually find the other videos to this series in the playlists. Okay, now I'm just going to switch over to what's actually displaying on my monitors and we'll head over from there. Okay, there's the monitor. And here we go. Now, just to start off with, you can have a look at our YouTube channel, which obviously you already are here. But under playlists, you'll find the introduction to KiCAD and the building 2x2. And you'll see, where's my mouse? There it is. There's the part 0, 1, and part 2. All right, and the guide that we're going to be following is this one here. As you can see, it's made by Rui Mao. You can find it on GitHub, and it's the keyboard PCB guide. So like I have done with every other episode in this series, I will be providing the link as well, so you can find it if it's not bookmarked, that kind of thing. So we've done the setup, schematics, the components, we've done the basic PCB components up to routing. And that is where we're going to get started. Now there is something that's not quite right, I guess is a way of describing it, in that last time when I put down the ground, and I did check that I had the right ground, the numbers on my ground components didn't actually match up to what is here. So instead of it being 1, 2, 3, 3, I actually think I've got 1, 2, 3, 4, but we'll see that. And you'll notice that you can use the V on your keyboard to switch layers and create a via. So essentially the via is where you're just going to be punching a hole through to the other side of the PCB. And that icon, which we'll show you in a second, in KiCAD is doing the actual routing or track. All right, that's I'm going to drag that across so I can see it on my other screen. Here is KiCAD. We've got our PCB file, the netlist, which is all the components, and the rat's nest. There's the schematic, and we've got a library that's being cached of components. So if we open up the PCB, that's what it looks like. You'll see all these white lines here in between the components. That's the rat nest, and the rat nest essentially tells you all of these components need to be connected through an actual trace, through a route. Now the routing button is over here, add tracks and vias, and let's get started. So I'm just going to read through the actual guide verbally rather than putting it up, and it says, now that we've gotten that out of the way, let's set some ground rules. Well, one ground rule, namely no vias between the crystal and the controller. Vias can potentially lead to small amounts of capacitance that can actually affect our crystal operation, so that's a big no-no. Let's start routing. The first thing you want to route is always the crystal and the decoupling capacitors next to it. Luckily for us, this is fairly simple. To get started, make sure you have the back copper layer selected, or the B.cu layer, which is up here. So we're going to go down to the BCU layer, because that is where most of our components are. And then of course they have the diagram on how it's done. So I'm going to go to the render. I'm actually going to turn off the rat's nest so you can actually see the components. We'll go back to our layer. We'll turn on our wire tool and let's start hooking up. So you're going to click in the middle of a component and it gives you that relationship. It says, according to your schematic, it should be connected to that component and it should be connected to that component. But now, so I've just gone and clicked down here and you'll notice that I've lost a whole lot. So let's try that again. We're going to go, can we connect there? Alright, so we need to actually create additional pathways, and I think if you double click, yeah, the double click fixes that, and there we go. So that's that done. Now we go to our other component here and it says we're going to be going up to 2. Now why didn't it do that? There we go. And my 2 is somehow got to get around. So this is why I'm saying it's a little bit weird, because I've actually got this 4 here, which according to the guide, oh, let's just back that off a little bit. I'm going to bring the guide back over. You'll see it's 1, 2, 3, and 3. But I'm not quite sure. Obviously, someone who's got a bit more experience, who knows what's going on here, they might be able to help me out later, but we're just going to just plow on ahead, because as an example, obviously, as long as you know that I've got mistakes in here, we're kind of going to be okay for the moment. Actually, if I go there, it says I need to still get that connected over here. But it's not a direct connection, so we do still need to go from here and around somehow. So let's see if we can do a dodgy. Go from there. And we've achieved a connection. Now, that's a really horrible workaround. It doesn't look pretty, but it gives you an idea of what the software is like. And yeah, essentially that's that's me not doing a very good job. Now, if I go back to the guide, maybe it's a little bit easier. Let's route the VCC. Make sure you route decoupling capacitors to their VCC pins on the microcontroller, and don't forget to route to the USB port. So what he's talking about there is there's the actual VCC in his version, and there's the routing which runs along down here, and then to each one of the components within the VCC. So let's have a go at that ourselves. Okay, let's zoom out a little bit. Which way is it? There we go. VCC, rightio. There's quite a few VCC components, but we'll go there and there. We can go from that one and we'll go across. Why won't you do that? There we go. There's another VCC there. Connect that one. We've got another VCC there. Now, I don't know if this is going to cause headaches later on, because you're going to have issues getting to ground paths if you cut yourself off. And we might actually find that later. Oh, you'll see I've done another weird kink over there. And then we've got a... Oh, that component needs to be rotated. Will that let me do it? No. Alright. There we go. That's a little bit better. Is that because it's not flipped? Oh well, either way, I guess we'll find out in the end. There's a VCC which we can go straight across, and then from that one we can run into that one. And as you can see, that one is highlighted, so we want to get a path that we can safely run across. And there we go. All right. So that seems to be kind of matching what they've got done on theirs. Let's go down. Let's route the U capacitors and the rest of resistors, keeping in mind that a well-designed PCB will look aesthetically pleasing. Now, I'm going to be the first to admit that my PCB that you can see us doing as this live example is going to be far from aesthetically pleasing. But if we did actually manage to get it right, at least it might be functional more than anything else. The U caps and the rest of the resistors. So let's bring that back over again, and oh, look at that. That's a really difficult way to get from there over to there, isn't it? And you're probably gonna have to do that one via a via. And this one, let's see if we can get out this way. And as you notice already, it's there's a bit of thinking that you got to do as you actually do this process. Now, having watched, or as you're watching this, it might give you some ideas in regards to how better to actually set up your component layout, which will make things a little bit easier in regards to how you're going to actually have your traces later on. Because, you know, obviously, if it's been badly traced, it's potentially going to cause problems, or it's going to look ugly, etc., etc. Now, I can't hop over this line because you'll see it crosses right here. So we're going to actually use the V, and we're going to punch. Will I be able to use a V? Maybe not. All right. Is that going to give me a V? Ah, there we go. Okay, so you'll see. I'm going to. There. So the red color actually indicates that it's going through the layer. And yeah, it allows you to go under or over components, depending on how you look at it. At this point, actually, while I've got this large switch hooked up, and you can see the column 0 and the actual row bits here. You'll see row 1. I was told by a friend of mine who has done a bit of PCB work with KiCAD, and they said ultimately what you want to do to make your routing easier is to make sure that all your column traces are on one side of the board, and then all your row traces are on the other side of the board, because it stops you having that really awkward crossover. Now, how you manage to achieve that, I'm not entirely sure when you have a scenario like this, because in order to get past that, you don't have much choice except to use the via and travel on the other side. But then if you're going that way horizontally across them, you're still going to have to use a via to actually get across these two lines as well. So yeah, if we have a look at the actual guide, you'll see these red lines with these white dots, and that's actually when they've used the via to cross under or over, depending on how you look at it, to the other side of the board to bridge these lines. Now, I'm kind of realizing that I'm not going to do a very good job here, but we're just going to draw a couple more lines to show you kind of like how it's going to look. So let's just draw from that ground, and you'll see how I'm pressing the V button and it's hopping all over in and out of the actual board to get to, I've lost it, where my component is going to be. And so if this was actually a serious trace, which obviously it's not, because this is just for the purposes of demonstration, we're on our current layer, we're punching through to the other side, we're traveling, we're coming back onto this layer, then we're going back under to the other side, and then coming back up on this layer again and to the other connection, which of course would allow you to run something like that straight through, because it's not going to be, you know, conflicting, because the red lines indicate that you've gone across to the other layer. And I think it's because my grid lines aren't set up very well, and I'm not clicking exactly on the grid dots, which is why I keep losing the connections or something. Is that going to work? Is that going to work? No. It might be actually because these components aren't meant to be connected, so it won't let me connect those components as well, which would actually make perfect sense, because why would you connect components that you should not be allowed to connect according to the schematic? Hey, there we go. Okay, so I've run this VCC line to this other VCC straight over the top of that because it's gone on to the other side of the board. Now, I'm not actually going to, I've just made an executive decision for the purpose of this video, because this is going to take a very long time if I actually try to lay it out neatly and correctly. But we're going to go back to the guide and pretend that I had actually done all of this correctly. And then Rukimau goes on to say that they've changed some of the routing to accommodate for the data resistors, and you can turn on the rat's nest in the render to see what you may have missed. So what they're talking about is, if we go back to the render and then you turn this rat's nest on, some of these white lines have actually disappeared because we've done the trace. So as you do more and more of these traces, more and more of these white lines will disappear, and it'll allow you to see what you have actually missed. So for example, if we connect this column to this column, for whatever reason, if it's going to work. Oh, come on. Are you gonna play nice? No. Okay. It's not gonna play nice. What is going on with my mouse? Alright. Let's turn off the rat's nest and let's try and do this again. Doesn't like it. Maybe I have to do it onto the copper, or maybe not. Yeah. If anybody knows what's going on, I would love to hear from you. Alright, so I've gone and connected that, which goes from one point of the switch into the diode, and if I turn my rat's nest on, you'll see the equivalent line from there to there is now gone. Now if I try that again, yeah, there you go. So that worked. Obviously, I'm not doing the right thing with these columns to whatever they're connecting to, but a bit of playing around will probably figure that out at some point. Let's go back to the guide. And you'll see most of the rat's nests are gone, and the rat's nests are getting smaller in number until they finally route everything. And then they're going to go back to using that plane fill. So the plane fill is how did we do that plane fill again? That's not what I want. That's what I want. To fill in your zones, turn on your zones, fill in any missing ground planes, press B to update the zones, and voila. Alright, let's go back to that. I think, there we go, filled in the zones, and we haven't actually, you'll notice that some of this is not quite right. I don't think there's any issues with the zones because there's no black spaces except for where the black spaces are. So I think we're kind of good because this is showing you where the actual, those paths are going. There's the copper to copper there, which I guess must be good. Let's turn that zone off again. Let's go back to the guide. Now we're not going to use this design check rule because it's going to show all sorts of errors. Actually, maybe let's do it anyway because it's going to give us something to have a laugh at. Now, where is my design check? There it is. Perform design rules check, and we'll say start the DRC. Okay, so there's no problems or markers, but it tells you right now that there is a lot of components that are unconnected, which is great because it's doing exactly what it should be doing. If there's nothing on both tabs, congratulations, you've got a working trace on all of your components. Back to this, and now we're going to go on to the rendering component. So earlier to this, I actually installed the rendering software, which is Wings 3D. It is actually covered in the setup component. Where is it? I'm trying to remember where that is, but there is actually a bit of software that you need. Maybe they talk about it. Wait, why is it not working? All right, let's go back down. All right, so for some reason I can't locate where the actual render is, but there is actually a bit of third-party software that you do need to actually install to get the actual rendering, and it's called Wings 3D. I found it somewhere in this guide, so it's obviously here. I just can't find it right now. And if we go to View, 3D View, turn on Preferences, Realistic, and then it should generate. So let's shrink that. Let's go to View, 3D View. Now the actual bit of keeps losing the snap. There we go. There's the 3D viewer. You can sort of see there's all the components that it's rendering, and there you go. That's what my horribly routed, poorly routed 2x2 components look like. And you'll see they're all surface mount components on this side, and there's nothing on this side except for the punch through holes. Yeah. What can I say? Let's go to is it realistic mode? There we go. There's realistic mode. So we can try and rotate that around, and you'll see there's the 2x2, there's the crystal grounds, there's the actual traces, and if we technically flip, you'll see they're the actual vias that I punched through as well in my random punching. But you can't actually see the wiring because I think it's in the middle layer rather than it showing the traces on this side. I could be wrong, but I'm definitely no expert in this. Now, we're going to just keep going very quickly into doing the Gerber files and so forth because it's fairly straightforward. We don't have any mounting holes that we're worried about here, but as I said, you can Google on how to add mounting holes, or if you can find a footprint for mounting holes, it'll just be like how they've done it here with the actual PCB holes in the footprints. Sorry, with the switch holes, not PCB holes. What am I saying? And yeah, you'll be able to put them wherever you want for screws and standoffs and so on and so forth. Now we want Gerber files, which are essentially instruction files for the PCB manufacturing systems out there that can produce your actual PCB. So we want to use the plot, we want to use the layers that we have stuff on, and make sure the Protel file name extensions option is ticked, and the format is 4.6 unit millimeters. And there's the example of what you should be doing. You just drag that off screen. So the plot icon is up the top here, and we're going to have Gerber. These are the layers that we're interested in if we had stuff on it. Now, because I don't have any silk screens, I can turn them off. I do have edge cuts, so I want to make sure that my edge cut is on. I do have front copper, I do have back copper. I don't have any sort of paste layers because, well, I might as well tick them anyway, because anything that's not on there on those layers, it's not going to generate regardless. Let's see, use the Proto and the 4.6 mil units as it says. And then we hit plot. So it's gone and generated a bunch of files that you can see here. It's generated each one of those layers as a file that is required for the Gerber. Then it tells you to generate a drill file. So we use a drill file. Now the output directory should be the same directory, the 2x2. Okay. Yeah, sure, let's use a relative path. We want to make sure that it's on PostScript. mirror y-axis is unchecked. Everything is in inches because that's what our grid system was in. And then we're going to hit drill file. So it creates the DRL files for the actual package. Let's go back to the guide again. Now we want to put all of those files into a zip file. So you'll see there's the drill file, there's the Gerber files for the different layers, including edge cuts, which is very important. If you don't have edge cuts, your board's not going to have any edges cut on it. It's just going to be one infinite continuous sheet. And then there's the path drill file there as well. So let's go back here and we'll close the dialog. Close the dialog. Now we do actually need to get to the directory that's in. So there's my desktop. Let's find my way there if I can, without giving away too much of what my computer has. Program files, KiCAD, 2x2. Alright, let's go back here. So there's all those bits and pieces, and we want essentially, now it's probably a little bit easier if you generate this in its own directory, and that way you don't have to figure out which ones to select. But I know that the PCB file and the back file, all of that stuff is all not related to the Gerber, it's related to KiCAD. So we can just send that to a zip file. There we go. And then we have, there's the 2x2.zip. And then we can chuck them into something like Gerber view. So if we go into Gerber view, we can choose the file. Defaults into my IE temp for some reason. So KiCAD 2x2. Alright, so there's the 2x2 zip. We open it. I say yes, I agree, you can have it. Anybody who wants to knock off this 2x2 is going to have a bad time. And then over here we can tick all of these options, and it will start to show up all those layers and all those components. And voila, there is your PCB. Now if it comes up and shows exactly the way that it's supposed to be, the way that you've drawn it, then there you go, it's ready for production. And then you can upload it to places like, you know, Seed or any of the other websites that do PCB manufacturing. Let's go back. Now I did actually put my file into PCBWay and I put it into Easy EDA. I didn't put it into OshPark. I'm not sure if I put it into Dirty PCBs or not, but I put it into Seed, and following this process it did actually work, and I was able to get a quote even though it wasn't a functional board. Like, they don't care. If your board doesn't work, if your PCB is badly drawn or created, they're still going to make it for you. It's just your own problem that if it doesn't work. And there you go. And now at the bottom of the guide, for at least US people, it's easy to get hold of this stuff through DigiKey, and they've listed all of those components that they're talking about. And indeed, good luck and have fun building your own PCB. So we can kind of see the involvement in this. Like I said before, you know, I've had challenges trying to do the routing because I didn't lay out my components very well. I have challenges with this routing because obviously there's something funny going on with the crystal that I've chosen to use in this example, as well as the fact that I'm just not very good at routing. This is literally the second time I've had a go at this. So don't be discouraged. The first time that you route, it may not work. You might get really frustrated and you just want to chuck in the towel. But a bit of practice, bit of planning, foresight ahead can certainly make your life a lot easier. The gentleman or lady, whoever it was, Rory Kimel, I actually don't know their gender, who created this guide no doubt has a lot of experience, and they still made mistakes because in their guide, as you can see from the example, they had to reroute some bits and pieces to make it neater and actually work better. And there you go. That is creating a 2x2. Now, obviously, my example didn't work very well, but at least you'll have an idea of what is involved and how much time it will potentially take. I would say if you're going to start doing this from scratch, you would need to probably put a good 3-4 hours into it at least minimum, if you can work fast and you're not prone to making mistakes like I have. Whereas even following this guide, I would probably say it would take me maybe 5 to 6 hours to actually build this from scratch. And that's with the extra knowledge that I have now about using the shortcuts and using hotkeys and mistakes that I've made in my previous attempt versus right now. Alright, so let's switch back over to the other monitor. Alright, that was a bit of a long-winded way of saying that I'm very bad at making PCBs, but I do hope that if you're watching this and you've followed through the process in setting up KiCAD, setting up the schematics, building the relationship on your components, putting down the footprints, and then of course generating the actual trace routes, and then of course creating the Gerber files and uploading, you can see it isn't technically that difficult to do it. It's just a little bit more challenging to do it well or correct the first time. If you're not in a rush and you've got a lot of time, then you can take it slow. And because it doesn't really cost you anything, unless if you're very time pressured for a financial sense, learn from your mistakes. Have a good time. Build one, use the check tool and see if there are any mistakes. And then you can throw it into the 3D viewing render and you can see how well it looks. If you don't like the way it looks, go back and fix it. Start again. The more practice, the better. Maybe come up with some strange layouts and so on and so forth. But that is how you use KiCAD, following the actual PCB guide by Roy Ki Mao. Now I realize that you can't really see what my hands are doing in the front-facing camera, but you can see all the shadows that are happening over here because I'm very expressive and I talk with my hands. Quite often I just don't actually know that I'm doing it. So thank you very much for tuning in and following on through this series. Now, at the time of recording, it is actually Valentine's today, so I thought it was a bit appropriate to have some of my my Valentine's caps from the grab bag over here. I do want to sort of give myself a little bit of a self-promo as well, in that if you haven't seen on Mech Market, I have been making 60% sleeves as well. As a matter of fact, I've still got a couple over here. So, using my wife's sewing machine, which is right there behind me, as you can see in the camera, I've been making some sleeves in a couple of different patterns. There's some stars, there's, apple pattern, some brown sort of haze camo-like, a bit of a floral pattern, and so on and so forth. These are just the ones that I still have at the moment. But if you are interested and you would like a sleeve, by all means get hold of me, let me know, and even if it's not a 60%, if you give me dimensions, I can work with that with materials that I potentially have, because all the proceeds for that go towards helping us fund our podcast, which is hosted ad-free, the entire back catalogue, anytime that you want to go listen to, as well as it gives us play money to get more bits and pieces and kits and builds and keyboards so we can review them, talk about them, show them, and so forth. And rolling in from that, I've actually got myself down in for the group buy on a Let's Split version 2 with the acrylic cases from Jollymon. So once that rolls in, I'll get on to building that after the Gherkin, because I have a Gherkin group buy kit coming in as well. So thank you very much for coming along and watching the last part of the KiCAD tutorial / PCB guide, and I hope that you've learnt from my mistakes, and then at least that way when you come to trying out making your own PCB, you'll have a much better time. You won't be as frustrated because you're not going to be thinking, am I like the only person who doesn't understand this or get this right the first time, which definitely you're not going to be. And yeah, I look forward to seeing your comments. if you haven't already, would love and appreciate a like, share, and a subscribe as well to our channel. And make sure you check out all of our podcast series at theboardpodcast.com. So, until next time, as usual, happy clacking.